All right. B. I hope you're well rested from the big break, right? Same example. Part 5 of this long process. Remember, we're testing a difference. With sample proportions, we're going to have to use the standard error when we do a confidence interval. Okay? We're taking the standard error for the difference. Once we collect our data, what we're going to do, and we've done it before when we worked with one sample, we'll substitute the value of P hat 1 in for P1 in the formula. This comes from the data. This would be the 25% for the female smokers. And I'll substitute in P hat 2 for P2. That would be the percentage of male smokers. This would be the 20%. Now, it's called a standard error because it's not the exact answer. Clearly, if I took separate samples, if I repeated this, I'd get different values for P hat 1, P hat 2, and then the value of the standard error would change, right? So they give it a special name, they call it standard error. Here's the formula, SE for standard error of P hat 1 minus P hat 2. It's the same exact thing, just put hats on the P's. Big square root, P hat 1 times 1 minus P hat 1 over N1 plus, same thing with the 2's. P hat 2, 1 minus P hat 2 all over N2. Once you collect your data, you'll always be able to calculate this thing by hand, okay? Because we'll just substitute these values come from the data, and these are your 2 sample sizes. It says on the notes, then halfway down, using the Cecil College sample data, compute the value of the standard error for the difference in sample proportions. Let's leave the formula up. Let's put the numbers just right here. And so I'll just put equals. Let's summarize what we know. So our P hat for the females, we've got to work with decimals. Remember, was 25%, 0.25. And our sample size for the females was 120. Now all the ones are the F's, right? What else do we know from the problem description? P hat for the males was 20%, and the sample size for the males was 90. Those are the numbers that go into the formula. Here we go, plug them in. 0.25 times 1 minus 0.25 all over N1, which is 120, plus over here 0.20, 1 minus 0.20 all over 90. Whole thing gets square rooted. So on if you're using like a TI calculator, I would sort of find this part first, hit the plus button, answer plus, find that part second. I would never write down intermediate steps. With these decimals, you're going to lose too much accuracy. You want to try to get it all in the calculator. And then I would add those together and then square root the answer. Okay, so here it is. Pause the video. It's fun activity at home to see if you get the same answer I'm going to get. So the answer is 0.0578. If I put that down here in the bottom corner, make sure you can get that. This is not an algebra or a calculator class, but it feels good when you can get the same numerical answer that we're getting here on the board. And I want to write a little summary remark in terms of what on earth does this number mean. Okay, that's the standard deviation, or excuse me, it's the standard error, I should say, of the difference between those 2 sample proportions. Our difference was 5%. And what that's saying is I can sort of expect that difference on repeated samples to vary, sample to sample, maybe 5-6%, 0.0578. Okay? So I'm going to clean this up a little bit, and I'm just going to write that out. I think sometimes we get a little bogged down on just getting the correct numerical answer, and we have no idea what it means. We'd like for you to know what it means. All right, so I'll leave that there. Let's see here. So up here, just a little comment, which is about 5.78%. And what did I say here? This is a measure. This is a measure of pretty much how much we expect the p-hat for the females and the p-hat for the males to differ sample to sample. That 5.78% is a measure of the spread. It's a measure of how much we expect those to differ sample to sample. If that's the case, think about like where we're going with this hypothesis test. What was our difference? When we collected the data, we had 25% female smokers, 20% male smokers. That difference was 5%. If our difference was 5%, is that very unusual now that we know how much we expect them to differ? Not really, right? It's kind of like maybe one standard error away from what we'd expect. So let's keep that in the back of our mind as we proceed. All right, that was number 5. We're on 6, next page. Get this cleaned up. Now that we know that standard error, we can now create a confidence interval for the difference. In this video, we're going to do both. Well, in this lesson, this first example, we'll do the confidence interval for a difference and then we'll run the test. So with the standard error value calculated, we can now create a confidence interval for the true difference in the proportion of smokers at Cecil, females versus males. Here's the formula. We're really starting to get a little messy here. It's still my best guess, plus or minus margin of error. And so here's the best guess. Over on this side, this is going to be the difference in sample proportions. And all confidence intervals look like this. Give me your best guess, plus or minus this part over here, which would be margin of error. Okay? We know this already. Now don't get scared when I put the formula down. Over here will be p hat 1 minus p hat 2. And then I'll add and subtract. You can put this in parentheses if you want. That's the quantity over there. And now I've got this big square root thing, but I do need to stick a z number in there. This will tell me how many standard errors I need to jump out to be however confident that I want to be. And so big square root, here's your p hat 1 times 1 minus p hat 1 over n1. And here's your p hat 2, 1 minus p hat 2 all over n2. And the formula makes sense. It's like my best guess for the difference, males versus females, would be 5%. That's the 25% minus 20%. Then I'm going to jump out a certain number of standard errors. If I wanted to be 95% confident, I would jump out about 1.96 standard errors. If I wanted to be 99% confident, I would jump out more, right? 2.576. So here's the formula. Let's do it. Let's do it. It's got to be next, right? Now calculate the confidence interval formula. So if I flip the slide, calculate the 95% interval for the difference, females versus males. 95% tells me that the z number, let me get that star out of there. It's an old notation. Thinking of the old textbook here. Here's what I'm going to do. I'm going to go upwards here so we can leave the formula on the board. All right. Everywhere we see a p hat 1, that's the females 25%, 0.25. Every time we see p hat 2, that's the males 0.2. The z number 1.96, and our 2 sample sizes. All right. So I'm going upwards. Here's the formula. This would be 0.25 minus 0.20. That's the 5%. Plus or minus 1.96 times 0.25. Oh, $1 minus a quarter, 75 cents, right? 0.25 times 0.20 or times 0.75 over 120 females. 0.20, $1 minus 20 cents, 80 cents. 90 guys. I'll make you a deal. I'll do the left-hand side here. You do the right-hand side. Ready, set. All right, I'm done. So that's my best guess for the difference, 5% plus or minus that margin of error. You know, you could cheat. We know this was the 0.05, 76 or 78. Well, we already just times that by the 1.96. Turns out to be 0.113. And so, I don't know, seems weird working upwards, but my best guess for the difference came from the data. It's 5%. I'm adding and subtracting about 11%. Think about that for a second. We're testing for a difference. We're making a confidence interval for the difference. If I subtract 11% from 5%, aren't I going to creep over to the negatives? Right? I'll be like -6 or something like that percent. And when I add, I'll be up to like a positive 16%. And so that interval is sort of containing the number 0. And 0 means no difference. Keep that in mind. All right. If I subtract, let me squeeze it right here. 0.05 minus, I'm going to get negative 0.063. 0.05 plus, I'm going to get positive, and I'm going to just emphasize that with a plus, 0.163. You don't need to put the plus in there, but you do need to put the minus for sure. So if I subtract, I go negative 0.063. If I add, I go positive. These are differences in percentages, so I'm going to use every last bit of real estate here. That's about negative 6.3% up to positive 16.3%. That's the confidence interval. Very important numbers inside that one, and that's the 0. All right, you've got that. You can pause it if you don't. I'm going to flip the slide and interpret this interval. So, rid of this. Last part of this long example. Interpret the interval with the sentence in context. These are tricky. I've been doing this for 10 years, and there's still these intervals for differences sort of tricky to get them to sound good. Okay? Here's the formal. If I wanted to be super formal, I was going to put this in a journal or something. I could say this. We are 95% confident that the interval negative 6.3% up to positive 16.3% contains the true difference in smokers, female versus male, at Cecil College. Kind of a mouthful. Not very exciting, but it's correct. We're 95% confident that this interval here, the negative 6.3% up to positive 16.3%, contains the true difference in smokers, females versus males at Cecil College. Maybe we go casual next. And this is fine. Formal's fine, casual's fine. You've got to think of the order of subtracting, right? I took female minus male for the whole problem. Females had a higher number in the percentages from the sample data. This 16.3% corresponds to, if I'm thinking like plausible values for the true difference, could be as much as 16.3% more female smokers at the college. Could be as much as 6.3 more percent male smokers. And that's zeros in there. So if that's a plausible value, it's telling me that statistically there's no difference between the two. So plausible values approach to this, right? Plausible values. You know, with 95% confidence, could be as much as 16.3% more female smokers, all the way to 6.3% more male smokers. Could be. I mean, those are the plausible values for the true difference with 95% confidence. So my thought initially was that, you know what, the 25% female versus 20% male, kind of too close to call statistically, and this is sort of confirming that. This is saying, look, could be more females up to this much more males, which means that no difference is inside of there. Now, what would I need to conclude that, yes, there were more female smokers? So just think about this and then we'll wrap this one up. Just suppose, I'm thinking just to clarify this, suppose the interval went something like 2.29% positive up to positive 18.1%. And this was the difference. Now the whole interval is above 0. This is saying the plausible values would be, it could be from about 2% more female smokers up to about 18% more female smokers. Is 0 in there? It's not. This would convince me that, yes, there are more female smokers at Cecil College, percentage-wise. Okay, so you've got to be really careful with these ones for a difference. Does the interval go through 0, negative to positive, or is it entirely positive or entirely negative? And that's a key point. So, we'll see you again for part 3. Thanks for watching.